Meet Mr. Archimedes of ancient Greece. Long ago, Archie said,
"Give me a lever long enough, and I can move the world."
Yeah, okay. So Steve Mould says Archimedes was an idiot. So then the law of the lever is nonsense because he didn't do any experiments to prove it. He just said it, okay, because he needs it to turn out his way. Okay, he needs to validate, conventional physics. And it's just really flat earth physics. I mean, you can't deny that levers work, and they work because of not something called mechanical advantage. They work because they just convert momentums. They take a do I really have to draw it? They take something with a big M mass and a small v, and they figure out that there's equivalences, and that you can have a big V and a small m. And that's what levers do. That's all they do. That's all pulleys do. And he doesn't understand that this is only 2,000 years old. Okay, so levers were before Archimedes. Okay, so but Archimedes was the guy who's basically saying, look, this is a great tool, and this is how it works. And Steve Mould is saying, and Minute Physics is saying, no, they don't work at all. I mean, they lose insane amounts of momentum. I mean, they just kill it in gigantic volumes because they conserve kinetic energy. Yeah, which is useless. You can't move anything with kinetic energy. It never works. All right, so there's a bunch of clips, and we'll go through some clips from the video. So it's time to pick on the Minute Physics clips in Steve's video because they're garbage. I mean, real garbage. Extremely garbagey. Yeah, junk science. All right, so before I play the clip, let's just do real quick. I mean, it's just really quick. So I would argue that levers should be suspended from above just to make them even more of a balance. But regardless, the point is we could drop, a mass, and we put a mass at the same distance from the lever. We drop a mass. We have every expectation we'll get pretty much what we put in. The only thing we'll lose any energy to is the motion or weight of the lever. So the lighter you can make the lever, the more you'll get back. But you put in 100, and you can have every expectation you'll get 90 plus, maybe 95% of your energy out in the opposite direction with the same mass. Now, obviously, the whole point of a lever is to say, well, gee, I can change what the percentage, the time force scenario, by dropping the object here, taking half mass, putting it 2 units of distance. And I can have every expectation I'm going to still get the same momentum. I'm going to conserve the momentum, and I'll get 5% of the energy will come flying out of here in this object, going twice the velocity. This has twice the motion for one motion here. Simple 2 to 1. I can do 2 to 1, I can do 4 to 1, 3 to 1, and all of that. Now his argument, what he's arguing in the video, they are arguing it as a real scientific truth, that somehow, no, I don't get 95%, okay, because I have to conserve kinetic energy. He's doing this square root of 2 nonsense, and he's saying that this object can only travel at 1.4, okay, the velocity, not twice the velocity. So that's a loss of some 30% of the energy. So only 70% of the momentum will be conserved. Now, if I change it to 1 to 3, okay, 3 mass and a 1 mass, 3 distances, now they're going to say you're going to lose 60% of the energy. And if I make it 1 and 4, then it's 70, and then 1 and 5, it's almost 80%, 75% of the energy gone, the momentum gone. I'm only going to have this tiny little 15% of the momentum will be conserved. Obviously, levers would be useless in that circumstance. Archimedes clearly wouldn't say, give me a lever long enough and a fulcrum to place it upon, and I will move the... No, he wouldn't have bothered saying this crap because levers would suck. Plainly. They wouldn't work. All right, and they clearly work in both directions. There's nothing stopping the lever from working in one way, that is, you want to apply less force and you want more force over a shorter distance, or you can apply more force over a short distance and create a lot of distance. So an ideal lever will actually, you could put the recoiling gun on one side and you could have the bullet fly off on the other side, ideally. Certainly Archimedes would have argued so. And there was nothing wrong with that argument, frankly. It's still true today. Okay, it was true 2,000 years ago. So again, 2,000 years ago. I mean, just think how crude and ignorant the world was 2,000 years ago. They didn't even know what bacteria was, all that kind of crap. And these modern scientists are saying that somehow they got something that obvious wrong. And why are they doing it? Just to preserve a religious notion, a Holy Ghost theory of this moronic 1/2 mv squared. No reason to do this. I mean, I've used the example of voltage, okay, and amperage in wires, right? I mean, they're almost perfect correlates. The amperage is essentially the mass of the electrons being moved, and the voltage is essentially the pressure or the velocity. And you can perfectly understand there would be no good reason for me to square one of those and say that's what equals the watts. No good reason at all. All right, so it's just nonsense, and they won't account for the silly. There's no evidence defending it. It doesn't take 5 times the fuel to go 25 times the fuel to go 5 times faster. It doesn't happen. It doesn't take 100 times the fuel to go 10 times faster. It doesn't happen. Ever. All right, so let me just play these horrible clips. All right, so first off, he's not even smart enough, frankly, to make these levers the same size. If you're going to say they're going to store the same amount of momentum, obviously they should be the same size. So it really sort of ruins the animation that he doesn't even understand that, yes, I must make them the same size. That would be the smart thing to do. So his contention is the lighter object, the half mass, twice the distance, will not go twice as fast. And that's obviously exactly what levers do. That's exactly their function. They perfectly conserve momentum. And, perfect's a little bit of a dangerous word to use, but a well-engineered device will oscillate perfectly. Perfectly. And they'll do it over and over and over again, losing very little energy. Because the fact is, levers do work. They conserve momentum. The MV on one side will be a different MV than the other side, but as a total, it'll be the same. Big M, little v, big M. I mean, it's just, and again, they call it mechanical advantage as if there's some advantage built in. And there's no advantage built in. You're just using it as a conversion device. And there's advantage to being able to take the same amount of energy and make it fast or make it slow. There's advantages. But there's no extra energy and there's no loss of momentum. You have to conserve the momentum. So again, it was a turning point. Archimedes probably knew you had to conserve momentum. And, it's 2,000 years later and people have to argue about it. Amazing.
To disprove the free energy hypothesis, we should probably...
So again, it's the same accusation Leibniz made, that somehow momentum is a free energy theory, when momentum always works and it never creates free energy. Your theory is the free energy theory, the crazy idea that somehow the bullet has 1,000 times more energy than the recoiling gun. And you'll never collect it, though, but you'll just tell me it's there somewhere. Oh, it's just such bad physics.
Prove that the half-kilogram mass has a kinetic energy of 1 joule from a force perspective first, which is actually really easy. The key is to notice that the force on the half-kilogram mass is half a newton, because that's how mechanical advantage works, from the work equation.
So it's half, but it's over twice the distance. So let's just keep pretending you're not changing how how fast the damn object's going. Yes, it's half the mass, twice the velocity. That is the same momentum as one mass, one velocity. I mean, it's just so stupid.
We get half a Newton times 2 meters is 1 joule. You then get the velocity by rearranging the kinetic energy equation. And when you do that, you find that whatever the final...
So he didn't do it experimentally. This isn't anything he found out in an experiment. He's just telling us, well, the formula says, so the formula must be right, therefore we should all believe this crap, that levers don't conserve momentum. And again, just imagine how useless the lever becomes if I make the difference 10 to 1. Because then I'm going to be losing 99% of the energy is supposed to be gone.
Velocity of the larger mass was the smaller mass, instead of being double the velocity.
So obviously these wouldn't rotate at the same speed because they've got different masses. So again, he should have made the levers exactly the same size to indicate that really that's the whole key to it. You're actually moving the same amount of lever in both experiments, and so therefore the same motion of the lever, so they both lose the same exact amount of energy to moving the lever.
It's root 2 times the velocity of the larger mass. So that
root 2, so that's 1.4 again. So he's saying you lose 1/3 of the momentum in the 2 to 1 example. In the 3 to 1 example, you lose more than half. In the 4 to 1 example, you lose 75%. And in the 5 to 1 example, you're all the way up to almost 80. 80% of the momentum lost.
That's where my intuition went wrong. These two spaceships in these two different scenarios don't have identical experiences.
So he's saying it again. He's saying that somehow the lever makes the lighter object somehow is more work to move. Somehow it's a lot more work to move. 80 times, 25 to 5 times more work to move. In the case of the bullet in the gun, 1,000 times more work to move. Absolute nonsense. No physical evidence ever collected saying any of that is true. And yet here he is publishing this frickin' dogmatic dogma, this propaganda for a nonsense theory. A nonsense equation. Invented. Not because the evidence, not because a bunch of experiments showed it to exist. Merely because a couple of religious kooks says it must exist because God wants it that way. That's the only reason why this thing was invented, is by God bothering. All right, so
one of them moves more slowly. But I still think it's a compelling line of reasoning. Like when I
yes, it's compelling, but I'll ignore it because I have to defend the Holy Ghost, and that's all he's doing. He's just defending dogma, propaganda, pseudoscientific nonsense for which he cannot produce any experimental evidence demonstrating it works or that it exists or any of it. None of it. You can't show kinetic energy moving a rocket. Can't show kinetic energy being collected by a ballistic pendulum. Can't show kinetic energy in a collision. Can't show it ever. All right. A 10-ton train going 5 miles an hour crashes into a 5-ton train going 10 miles an hour, and twice the kinetic energy will not result in victory. The tug of war will say, nah, that's the same energy. Those are the facts. And these liars just keep promoting this nonsense because they won't do the experiments, because the experiments will demonstrate they're frankly idiots. All right. Defenders of religious dogma. All right, so I've already played this once, but yeah, we'll play it some more.
Presented it to smart people. It hasn't persuaded them that you can get 2 joules from 1, but at the same time, they weren't able to immediately tell me where I'd gone wrong. I bet
right. And so now just talk about making a free energy machine. I've already shown the diagram of the free energy machine based on kinetic energy multiple times. So, I mean, you're the ones promoting the free energy theory. The magical energy theory, the scalar, magical, invisible energy, the velocity without a direction, speed without a direction. Yeah, bullshit. All right, let me go find the minute physics nonsense. All right, so unfortunately, he does have his voice sped way up, but whatever. That's his thing, his shtick.
Because rotating things are complicated, but when I sat down and did the calculations, I noticed that I didn't really have to rely on any physics.
So the calculations, I didn't have to rely on any calculations. So he's just showing a bunch of fake nonsense here that there's something complicated where the conservation of momentum is a challenging mathematical equation. It's not challenging at all. You conserve the momentum. There's no way to do it, not to do it. And the whole idea that somehow lighter things have more inertia. When you try to move something faster, it has more inertia. When there's no evidence that it has more inertia. Okay, twice the force, twice the velocity, as Newton said. 3 times the force, 3 times the velocity, as Newton said.
Specific to rotations. Ultimately, the two different masses are distinguishable when you waggle the lever,
Says you. Yes, says you. Purely because I'm going to write a formula, not because I have any evidence that they could possibly make any difference.
purely because they move different distances.
So, yes, completely proportional to their masses. The thing with half the mass moves twice the distance. The thing with one mass moves half the distance. Gee, not complicated at all. Exactly mv, mv, right? And big M, little v, smaller m, bigger v. Yeah, not hard to figure out at all.
Little mass on the twice as long
I mean, he has it written right there. 0.5, 1. This one will move 1 unit of distance. This one will move 2 units of distance. Obviously going twice the velocity. Duh. Now, yes, you can move them at different velocities and make them feel different. Anytime you move something at a different velocity, it'll feel like more work because you're making it go faster. So if you move them at the same speed, right, if you're obligated to move them at the same speed, you're not going to be able to tell the difference.
lever moves twice as far for a given deflection of your hand. This got me thinking about other places where...
So he didn't say anything there to debunk the basic statement. He just basically said, with a bunch of gibberish and jargon, he just said, quite clearly, big mass, okay, small v equals big V, small mass. That's exactly what he just showed. Hey, it's funny how you don't see that on the white screen. Well, it's not funny. It's irritating. But whatever. I did write it. Even though you can't see it. All right. Continuing. You've already seen it. You should be able to follow along. Should be able to follow along. You're humans. Forget it. I might as well be talking to lumps of dirt.
Identical force applied over a fixed distance can result in objects moving different distances.
So this pushing a box is about friction. So again, what does that have to do with these experiments where we've tried to isolate the object from any kind of significant friction? So again, more BS. Put your box in space and you have exactly the same scenario. What force does it take to move the box? If I want the box to go twice as fast, what do? Do I apply twice the force or do I apply 4 times the force? That's the simple argument. And the simple fact is you just apply twice, as Newton stated.
Which made me think of pulleys. Like, you could hold up a 1 kilogram object with a rope over a pulley like this, or a 0.5 kilogram object with a pulley set up like this.
Okay, irony all over the place, right? So, I didn't point this out in the first video, but the 1 kilogram is going to animate. So see, everything went so fast that that's the problem with these minute videos. They're just too damn fast. So he can say anything, do anything, and you're going to believe it because you can't follow along. It's just too damn fast. The 1 kilogram is going to move half the distance. The 0.5 is going to move twice the distance. Quite obviously, the 0.5, if you pull the same way on both of those ropes, the 1 kilogram will move 1 unit of distance. The 0.5 will move 2 units of distance. That's exactly what will happen. It's a perfect momentum conversion. That's all the pulley is doing, is converting a big M, little v, into a big V, little m. Period.
And the force you'd experience would be the same. Feel free to pause and think
Right,
about it.
so
For you to
the
pull
force-
your rope 1 meter, the 0.5 kilogram object will move 2 meters, while the 1 kilogram object only moves 1.
So we just said it. And obviously, if you pull exactly the same on both of them, it feels the same. It's the same 10 newtons, so obviously it feels exactly the same. You're pulling exactly the same. If you pull it at exactly the same rate, that's exactly what will happen. The 0.5 will go twice the speed. The 1 kilogram will go 1 unit of speed, velocity. It's a momentum conversion device. If you put more force in, obviously you'll get more speed out. You put less force in, you get less speed out. But if you put the same force in, you're going to get the two equal results. You're going to get 1 kilogram moving 1 distance. You're going to get half kilogram moving 2 units of distance, 2 units of velocity. So he's proving the point here. He's saying this is the law of the lever, the law of the pulleys. It works. He's claiming it conserves momentum in the very video where they're saying levers don't work. I mean, the irony. I mean, he just proved the argument. And now look, watch this part. This is the part where you're just saying, what kind of bullshit is this?
Just like the rocket lever thought experiment. And the rest of the math works out identically to the levers.
Oh, so more bullshit about some sort of math that has to work out. Or these loopy lines and stuff, like pretending this is somehow complicated. No, not complicated. I mean, it's really not complicated. Big M, well, you know, little v, little m, big V. Not complicated.
If you hid these two pulley setups inside boxes, you could tell...
See? What did he do? What did he do? If you hid the pulleys in the opposite direction, that is, if you put the half mass where you have to move it twice the distance and the full mass and you have to move it 1 distance, if you're testing from the wrong end of the lever, right, the end that has the different masses on it, then you'll be able to tell. Yes, because of course you're converting, you know, 2 different MVs. You're not using the same mass and the same work that you're going to get on the other end. You're not supposed to test it there, idiot. You're not supposed to be testing the part of the pulley that's moving with the different amounts of velocity. You're supposed to be testing the 2 other ends where the constant force is going to be, where the equal force is going to be. That's where you're supposed to be testing. I mean, what a fucking cheat. I mean, of course, if I'm catching the half mass moving twice the velocity or I'm catching the full mass moving 1 velocity, I can see they're different.
Which was which by pulling up and down on the rope. The equivalent of wiggling the lever. It's kind of like the pulley
So
setup.
you won't be able to tell. If you're here, see, now he's got the 2 guys on the outside with the 10 newtons. They can't tell. From that perspective, you can't tell which one you're doing. If I hid them and they can't see which one they're pulling on, they couldn't tell the difference. Now with pulleys, obviously you're doing 2 pulleys here. I think there's going to be more losses to friction, so you might be able to tell. But with levers, you're not going to tell because the lever moves identically for both experiments. Oh, this is so fucking bad. I can't believe I am the only person of the million people who watch this garbage video, I'm the only one who can say, wait a minute, that's completely wrong. You can't sit there and make this idiotic argument. There's not a single person with any kind of physics knowledge that can make a video and say, hey, you know, Steve Mould, you just did it. This is garbage. This is flat earth stupid. You can't say this shit without doing the experiment and claim it as a truth.
Gives the small mass a higher moment of inertia, or whatever the equivalent of that is.
Well, how's it got a higher moment of inertia? It's less mass. It's easier to move. How's it got a higher moment of inertia? It's just such a pile of shit, this rhetoric of this fucking inertia word. It's got higher mass because it's a half mass. No, it doesn't have any higher mass. It has less mass. It moves easier. Oh, shit. Jesus, it's like it's a glass, and it's you have a certain amount of water. Now the glass is smaller, so you can fill it twice. I mean, duh.
Is for pulleys. And you can also contrive a similar but not exactly
Okay, contrive is a great word because that's all you people are about. And so even what he says here, it doesn't make any sense, right? So listen to this shit.
same situation with inclined planes. So I think this whole puzzle...
So you can contrive it, he said. So you can contrive a circumstance. Well, yeah, he says it in the next clip. where you could actually contrive a circumstance where you can't tell the difference. So you'll duplicate the lever in the sense that you get twice the velocity and you won't be able to tell the difference. And somehow you can do it with an inclined plane, but you can't do it with a lever. If it's a principle, if you're saying kinetic energy must be conserved, then you can't throw this inconsistency out here and say all of a sudden it doesn't have to be. I mean, this duality crap is such nonsense. Oh, jeez. Such garbage physics.
Is more about the mechanical advantage of these scenarios.
So he said it again. It's more about the mechanical advantage. There's no mechanical advantage. There's just conversion of momentum. That's all you can do. There's nothing else you can do in this frickin' universe except change big M's and little V's into little M's and big V's. That's all you can do. There's nothing else that happens in this universe. And you don't have any experimental evidence proving anything else. Any other credible experimental evidence.
At least mechanical advantage applied in such a way that it results in an object moving a different distance than your input force moved. Because, full disclosure, there are also ways of setting up a situation with inclined planes where you really can't tell the difference between the two different masses. Because
there we go. So he just said it. Well, what do you mean? There's something magical about the inclined plane where all of a sudden I can do what a lever can't do? Bullshit.
the force you experience is the same, and they both move the same amount. So I think it's about...
if they move the same amount, then they can't have the same energy if they're two different masses, can they? So that's kind of a bullshit statement out of him, right? I mean, you hardly have the same, half the mass going the same speed certainly can't be the same energy.
How mechanical advantage allows you to convert the magnitude of the motion.
So really it's about mechanical advantage.
Whatever the hell that means, right? So what the hell does it... Oh, it's really about mechanical advantage. What does that mean? What does mechanical advantage mean? I mean, all I'm trying to do, if I'm trying to lift something really heavy, all I'm trying to do is turn a little motion with a ton of force and doing it with a big motion with a light force. So I'm doing a big velocity with a light amount of mass on one side to try to push up something on the other side, right? So I could do it with just mass, right? I don't even need to apply a force. I can just let gravity do it, right? I can create a lever. Can't say I ever did this because, you know, it's kind of a pain in the ass to do it this way, right? It's so much easier just to apply your own energy to something. But I mean, I could have the scenario where I want to move something, a big rock, and all I can do, I can put a little basket on here and I could just load it with weight. All right, and I will be doing exactly this conversion. I'll be taking a small mass, okay, at this large distance, and let it, okay, apply a force significant enough to move this a tiny distance. And I'll be able to do it. I'll have a, you know, I'll have a big V and small m here, and I'll have a little v and a big mass here. And that's all that's going to happen. That's all the lever ever does. That's what it does. That's its function. It converts momentums. That's it. And it does it does it very efficiently and proficiently. And these fibbers are trying to convince everybody that somehow they don't work. That Archimedes was wrong, that levers are dysfunctional pieces of garbage. And we know that it's only the limitation of our materials, that we can make levers that can be incredibly powerful if we could solve the material problem of the mass of the lever. Because obviously the longer the lever I make, the more energy it consumes out of the experiment. Duh. Because it's moving mass. So it has to be a small percentage of the total mass of what I'm doing, or I'm not going to get very far in a lot of cases. In this case, it wouldn't hurt me at all because I have a giant amount. If I use a very heavy lever, it's to my advantage because I have a bunch of lever on one side of the fulcrum and a small amount on the other side of the fulcrum. So the lever alone could do it, right? We've probably all done that, right? I mean, I have a big steel, I don't know what it's called. Just a big steel rod, okay? It probably weighs 25 pounds, 30 pounds. And yeah, so in some cases, so all you got to do is wedge it, you know, under something and just let the weight of the heavy steel lift it up. So, I mean, this is just such bad physics. They're propagandizing. evil, stupid crap. And nobody will show up and say, hey, you know what? That is really bad physics. These guys shouldn't be talking to kids because they shouldn't be, filling kids' brains full of this absolute garbage. Levers don't conserve momentum. You're an idiot.
Which, interestingly, was the central premise of my last video about Brennan torpedoes.
No, it really wasn't. That was much more complicated, but whatever.
Coincidence there. The famous thing about mechanical advantage is there's a trade-off between force.
It's the famous thing about mechanical advantage. So again, this trade-off, there's no trade-off. It's a conversion device. A really simple conversion device. You just move the fulcrum or you just change the distances of the masses, and it allows you to do this wonderful thing of converting big M and little v into big V and little m.
Force and distance moved. I don't require much force to move this mass up and down because I have mechanical advantage, right? But to get the mass just...
Right, and if you put the heavy mass really close and you move your stick exactly the same speed, you're not going to be able to tell the difference. And even if you move them different speeds, you're still not going to be able to tell the difference because moving them different speeds, you'll end up having to move the same. It's still the same amount of work. You can't change how much work it is. All right, and the only way you can change how much work it is to do it faster than, get out of gravity quickly. Anything you move through gravity, the quicker you move through the gravity, the less work you have to do. But in both cases, it's the same scenario because you're always these things are rigid. The stupid lever is rigid, okay? Something going one speed here has to go twice the speed here. There's no choice.
To move a little bit, I have to move my hand a lot. And I guess we can just extend that. So it's not just a trade-off between force and distance.
So there's no trade-off. You're not trading anything off. You're just converting momentum. And you're doing it really efficiently. That's what levers do. They convert momentum and they convert it really efficiently. And that's all somebody needs to know. There isn't anything else. There's no other component. There's no inertia subject. There's no frickin' kinetic energy subject. There's just momentum and there's just the conversion. And that's all it does. It doesn't do anything else.
It's a trade-off between force and distance over time. In other words, velocity. It's also a trade-off between force and distance over time squared. In other words,
all right, so nonsense part. So bullshit. Just absolute old nonsense. It's just a conversion device. The end. All right, I don't think there's anything else here worth listening to. Can't see. Let's see. He just keeps doing the same crap, and then the minute physics guy comes back, and let's see what else he says. Because again, he's hedging his bet. So the minute physics guy comes back, because he's probably thinking, oh, gee, I just explained how pulleys conserve momentum. So what the hell am I talking about? Because that's what he just did.
Like holding a 1 kilogram weight for 5 seconds. But if you tell me I'm going to apply a force over a given distance, which was the original setup, while that sounds super similar to our brains, it's actually a very ambiguous statement. Lifting a 1 kilogram weight a meter could take 5 seconds or 5 hours.
Right, and you can do the experiment both ways. It doesn't matter. It doesn't matter whether you're lifting the 1 kilogram half the distance or you're lifting the half kilogram twice the distance. And it doesn't matter how fast you do that. It's always going to be the same work because it's the same exact momentum.
Those would be very different experiences.
So they can't be different experiences because it's exactly the same momentum. And that's exactly what the device is showing you. Oh, God, it's so bad.
yeah, that makes sense.
No, it doesn't.
I like that. Any other theories from viewers? You can let us know in the comments.
Oh, yeah, you won't pay any attention. So what's the point of let us know? I've tried that. For 3 years, I've tried that with you. There's no point. You're completely disinterested in anyone proving you wrong.
What does all this mean for my double-decker Newton's cradle?
Okay, so we won't bother with that. Ugh, jeez. Anyway, his double-decker Newton's cradle, he can't even figure out that the length of the lever, he's got to use the length thing. You know, that would be the important thing to do, is to change the ratio of mass to velocity and see what would happen. But anyway, it doesn't matter. All right, I'll see if there's anything else. I don't think there's a reasonable comment on the comment boards. I guess I'll just comment on the commenters. And this same bullshit keeps coming up, like, I should do all of these experiments. Now, the fact is, I have done them, and these liars just keep saying this shit when I've already done them, all right? And the fact is, unless they're done very well, it doesn't establish a proof. Don't you get it? Can you understand that? That just like I'm not going to believe some guy who takes matchbook cars and puts 4 pounds on one and then bangs it into a cracker and tells me he's collected the kinetic energy. I'm not going to say, oh yeah, you just proved it. And yes, we all can believe now because you proved it with your fucking matchbook's car crashed into a cracker. Yeah. That's not the fucking goddamn proof we need. And it's been 350 years you're claiming this Holy Ghost exists. MV squared has been around 350 frickin' years. You should come up with some fucking evidence. Show me the evidence. You show me the Mythbusters crashing cars where, yeah, the car going twice as fast is crushed 4 times as much. Show me that piece of evidence. Show me, turn on a drill and show me the amperage meter and show me that, oh, look, you know, if I move the drill 5 times as fast, it's 25 times the wattage. Show me, you little lying putzes. But yeah, I'm just going to be an instant block. Anybody who says I have to fucking prove your theory, fuck you, I do. You're claiming a Holy Ghost. You should come up with one shred of fucking evidence for it. All I have to do is point out all the experiments that say it fails. And that's what I've done. I pointed out you can't collect your kinetic energy in a ballistic pendulum. You can't collect it in a tug of war. You can't collect it with hydraulics. You can't collect it with gears. You can't collect it with levers. You can't collect it with a spaceship. That's all my obligation is, jackass. Oh, these people are such duplicitous hypocrites. Okay, enough said. I've drawn it, I've explained it, I've linked to it. Fuck you, okay? Defend your physics or prove that you're just a dogmatic religious kook claiming I have to respect your Allah. No, I don't. I don't have to believe in your holy fucking ghost, your 1/2 MV squared bullshit for which you have 0 experimental evidence indicating it actually exists. 0. All right, enough said. I hate this planet. Just hate it.